In this example, we're going to take a look at the Sanotronics simulation problem in Chapter 16 of our book. Take a second and either download the workbook off of Moodle or go ahead and begin to set up your workbook like I have on the screen here. We're going to break this problem into the 4 parts that they did in the book. In the first part, we'll create the static model that gives us one model. Then we'll set up the probability section, which will allow us to generate the random values given the properties of the values. Then in step 3, we'll set up the data table that will replicate the model 1,000 times. And then finally in step 4, we'll generate a summary statistics section and create a histogram that will help us to evaluate our findings. So the first thing that we need to enter from our problem are the parameters that they give us in the book. They give us what's called the base case, and they tell us that the selling price per unit is $249. They also tell us that our annual administrative costs are $1 million. Our direct labor costs are $45. Our parts cost per unit are $90. And then we are told that the demand in the first year is estimated to be $15,000. So the first thing that we want to do with these values is make them a little bit easier to read. It's hard to tell if this is 100,000, 10 million, what have you. So if you select on the cell, we'll go ahead and format this number. And we want to put the commas in there. And there we go. Now we can go ahead and copy that format down onto this demand cell as well. So that's easier to read, the 15,000. So now we want to calculate our profit. This is equation 16.2 in the book. And our profit model is simply our costs multiplied by, well, our price minus our cost multiplied by demand. Then we have to subtract the annual administrative and advertising costs. So profit equals so our price per unit minus our direct labor cost minus our parts cost per unit. We want all of that to be multiplied by our demand. So multiplied by the demand. And then finally subtract our administrative and advertising costs. That's the 1 million. So we can see, I'm going to copy and paint this format again. We can see that the profit in our base case scenario is $710,000 per year. So now we need to create a model that will tell, and to do that we need to know about the costs and the demand. We're told that the direct labor costs follow a discrete probability distribution, and we want to go ahead and set up a table. We're given some information in the book here. And we're going to enter our cost per units and the probability associated with that. So we are given a few costs. And then the associated probabilities. And we need to create a discrete probability distribution table for Excel to randomly select these costs in our model. We're going to use upper bounds and lower bounds to do this, and the upper bound is going to be used to create the next lower bound value. But it's the lower bound value and the cost per unit that we're really concerned with. So our lower bound is initially going to be 0. and we want to sort the costs from low to high. So then our upper bound is always the lower bound plus the probability of that cost. So our upper bound is going to equal the lower bound plus the probability of this cost. Okay. Then our next lower bound is the previous upper bound. So equals this upper bound. And again, our upper bound is the lower bound plus the probability. So now that we have these in here, we can go ahead and copy down our formulas. And we can tell that this is right because our first lower bound is 0 and our final upper bound is 1. Okay, so given the parts cost information, we're told that it follows a continuous probability distribution, and we need to enter our lower bound and our upper bound here. So our lower bound of the parts cost was 80 and our upper bound was 100. Okay. Now, a characteristic for continuous probability distribution is that the cost can take on any value between the lower and upper bound with equal likelihood. Okay, we can have any number of decimal places in there. Then the given demand information, we're told, follows a normal probability distribution with a mean of 15,000 and a standard deviation of 45 units. Again, we're going to copy and paint that format so it's easy to read. And now we have all the information that we need to go ahead and create the random values used in the model. So we are on to part 3, and we're going to set up our data table. We want to run 1,000 simulations. So we'll follow the book example, which sets up a data table. And the first step is to create a column from 1 to 1,000. Now you can do this by copying down numbers, dragging down on the lower right hand corner, or we can make it a little bit easier here, and we can enter in the first value in the series. So we entered a 1, place your cursor on that cell, and then from the Home tab you can go up and select Fill, We want to go to series. We want to be in a column. We want our step value to be 1, meaning that we count by ones, not 2s or 10s or anything. And then our stop value is 1,000. We'll click OK, and it should go all the way down to 1,000. Okay. Now, so from here, we're again told that the direct labor costs follow a discrete probability distribution. And we're going to use a random number generator, and that's called VLOOKUP function. Because the lower bound is in the first column, then we are going to enter equals VLOOKUP. And we want this to be the random, R-A-N-D, left parenthesis, right parentheses. Then we want to select our table here. We only need to go over to cost per unit. And we want that to be absolute. So lock that table in. Then our column index number, we are dealing with our third column. So 1, 2, 3, our cost per unit. 3, comma, and true. Our range lookup. True is an approximate match. Okay. When we use a VLOOKUP, it tries to find an approximate match. End parentheses, and here we see 46. Now remember, this is a random number generator, so things that I enter, every time I make a change, things are going to change. My table is going to look different than your table. That's okay because we're dealing with a random number generator here. Next, we look at this parts cost per unit. And again, we're told this follows a uniform distribution with 80 as our lower bound and 100 as our upper bound. We're going to use equation 16.3 in the book, and that tells us if we will take our lower bound 80, and then we add that to the upper bound minus the lower bound multiplied by the random number. And then we're going to get a continuous value. It's going to have some decimals in there. So equals our lower bound, again, all these are going to be absolute, plus our upper bound minus our lower bound multiplied by a random number. Equals, and we can see again, since I made changes, it regenerated my direct labor cost per unit, and now we have decimals in here like we said. We're going to go ahead and take away a few of those to make it a bit easier to read. But now we're going to look at our demand, and we're told that demand is defined in the text as following a normal distribution, and we want to use the normal inverse function, which effectively returns the value of the area under the curve. So we're going to again use that norm.inverse function, and so we'll enter equals norm.inv, and we want random. And we know our mean is 15,000, comma, our standard deviation. Again, these should be absolute cell references. Close parentheses. And again, this will give us a randomly generated value that's normally distributed around a mean of 15,000 with a standard deviation of 45. Again, we can take away a few of those decimals. And we see again we have changes to our other columns because of this random generation. Okay. So now we're going to go on to the profit equation. And with the profit here, it's very similar to the profit equation we used before. It equals the selling price per unit, which we want to be absolute, minus, now we're going to use these costs down here, the randomly generated selections, our direct labor, minus the parts. All of this will be multiplied by the demand that we found here. Then minus our admin and advertising cost. Again, that one is going to be absolute. Okay, and we can go ahead, make this a little easier to read again. We can copy this format, paint it on down here. Okay, and again, you see that everything changes once we make a change. So now we want to go ahead and do this for all of our table, our entire 1,000 trials here. So we go ahead and select our whole table, so all 1,000 trials. Then go up to the Data tab, then What If Analysis, Data Table, And we just, for our column input cell, we want to select an empty cell that we're not really using here in Excel. So this D1 is empty. Do that and select OK. And then it's going to take a minute for all these to run, but it did that without a problem. So now we can see we have all this information with all these randomly generated inputs that we have.